In this video, we're going to talk about when it's appropriate to use substitution versus elimination and the different types of answers that you can get. In previous videos, we've gotten 1 point as a single answer, but there are two other possibilities. We could have no solution or infinitely many solutions. So first, let's talk about which method is best when. So looking at these two examples we have here, you can always use either method. Substitution always works, elimination always works. The problem is that one is usually more efficient than the other. For example, on this problem on the left, we can decide whether we want to use elimination or substitution, but I'm seeing that it would be easy to get this y variable alone. So if I can easily isolate one of the variables, then I'll probably use the substitution method. It's going to be less work and I won't end up with fractions. Versus this equation on the right, or system on the right, if I tried to use the substitution method, since all the variables have a coefficient here, and those coefficients do not divide evenly into all the terms, we will end up with fractions. Now it's okay if you like dealing with fractions. It is possible and you can do it. It's just not the most efficient way, since it's easy to lose numbers and mix up fractions. So I'm going to go ahead and begin with the one on the right by using the substitution method. I'm going to take the first equation and get y alone. I'll subtract 2x from both sides, which gives me negative y equals negative 2x plus 5. And y is not quite alone. We have to divide by that negative 1. So y will equal a positive 2x minus 5. Now that I have this value, I can substitute that back into the second equation. So negative 6x plus 3, replacing y with 2x minus 5, equals negative 15. I distribute negative 6x plus 6y minus 15, 3 times 2x, 3 times negative 5, equals negative 15. Combine my like terms, negative 6x plus 6x, that's actually 0. Those have eliminated. And now I'm just left with negative 15 equals negative 15. Or I could even go one step further and add 15 to both sides and get 0 equals 0. Now what does that mean? My variable is gone, so I can't get a specific point. So that means that the answer is not going to be 1 point or one solution. This means it will either be infinitely many solutions or no solution. Since we ended up with 0 equals 0, or if you stopped up here, negative 15 equals negative 15, we've ended with a true statement, an identity statement. That means that these two equations are the same line. If I end up with something that is true, then that means there are infinitely many solutions. Meaning that those two lines are in fact the same line. They lie on top of each other. Try the one on the right. On the second example, like I mentioned previously, if we tried to use substitution, we will probably end up with some nasty fractions in there that we'd have to deal with. So instead of using substitution, I'm going to prefer and use the elimination method. And again, I can recognize that because all the variables have a coefficient other than 1 or negative 1. Now, before I can begin, I notice something going on here. I see that I have 4y on one side of the equals and 10x on the other side. I need to get my x and y's on the same side like the equation above before I can even begin. So I'm going to start by subtracting 10x from both sides so that my x's and y's are on the same side. So now I have 5x minus 2y equals 6 and negative 10x plus 4y equals 1. Now I've chosen to do elimination. I could eliminate the x's or the y's. It doesn't matter which one. I noticed that 10 is a multiple of 5 right away. So because 5 divides into 10, I only have to multiply this first equation by a factor of 2, and I'd end up with 10x and minus 10x for my elimination. So I'm going to take this first equation and multiply by 2. Whatever I do on one side, I have to do the same thing on the other side. I'm just going to bring that down below. So 2 times 10x is 10x. 2 times a negative 2y is negative 4y. And 2 times 6 is 12. Now I can do my elimination. So the goal was to get negative 10x and positive 10x, which I did. That's 0. But what also happens is I'm getting a positive 4y and minus 4y. That's also 0. So the left-hand side of my equation is 0. On the right-hand side of my equation, I have 1 plus 12, or 13. Now this is not a true statement. 0 does not equal 13. That's false. So do we think the answer is infinitely many or no solution? Well, since when we got a true statement, it was infinitely many, when we get a false statement, that means it's going to be a no solution. This means that the two lines are, in fact, parallel lines, and they will never cross. So there is no common point and no solution. So those are the other two types of answers that we could get besides having a single point solution.